Yeah. Good morning, all. I welcome Mr. Harsil Sa, who work as a business manager in Symmetric Solution, and today he is delivering webinar on understanding of SolidWorks. Harsil Sa has expertise in many domain, from training, product design, FEA, CAD, and CA. So I welcome Harsil Sa sir
Thank you,
for
thank you.
today's webinar. And sir, now it's from your side, sir.
Okay,
Thank you.
thank you. Yeah, thank you so much, sir. Good morning, everyone. As per our sir said, Kausal sir said that today we will deliver you about the SolidWorks software and the applications of the software in our mechanical as well as engineering segments. Okay. Before we start, basically we don't have enough time to introduce about me and my firm, so we'll directly move on to software and software's applications. Okay, then firstly we have to understand that when SolidWorks found. Okay, basically SolidWorks was developed in USA. Okay, MIT graduate person found SolidWorks in 1993. In 1993, SolidWorks was found in USA, and the firm name is SolidWorks Corporations. Then, in 1997, Dassault Systems. I think you all aware about Dassault Systems, right? Dassault Systems is basically aircraft manufacturer, defense aircraft manufacturer. Uh, Recently, you know that our Indian Air Force just purchased a Rafale planes, Rafale fighter plane. Fine. The Rafale planes developed by Dassault Systems. Okay, and Dassault Systems is basically origin from France. So Dassault Systems take over the software SolidWorks from that person. Okay, in 1997, in around $310 million. The deal was in $310 million. I think you all aware about, not aware, but just heard the name of the software that is Katia. Katia is already a product of Dassault System. That product, that software developed in 1975, developed by Dassault Systems in 1975. So that is the oldest CAD CAM and CAE software. Okay. Now, SolidWorks is basically used for product design as well as machine design and system design applications. Today's world, in today's industrial aspects, the most user-friendly software is SolidWorks compared with other CAD parametric software like Creo as well as Katia as well as Solid Edge or Fusion 360, etc., etc. Okay. Now, Dassault Systems have there are so many softwares in particular segments. Like SolidWorks is for product design as well as machine design. Then Katia basically is applications is automobile design, surface design. Okay, automobile as well as aeronautical design. Then 3D VR Simulia is also the product of Dassault Systems for different applications for analysis and all. Okay, this is the basic images from SolidWorks. We can do anything in SolidWorks. We can, as per all, we already said that we can do that we have to design in SolidWorks. Now, I already said that the SolidWorks was founded in 1993 by MIT graduate person John Histick, and in 1997, Dassault Systems take over from that person, John Histick. We can do 3D part modeling. Okay, 3D parametric part modeling, then surface modeling. Again, we can do 2D detailed drawings, same like AutoCAD, right? But in this softwares, we can create 2D drawings from 3D directly, automatically. We don't have to create manually. If we have a 3D model, parametric 3D model, then we can create 2D drawings automatically from 3D. Then we can create analysis too, stress analysis, finite element analysis, FEA, as well as CFD, computational fluid dynamics. Also, we can create in SolidWorks. Now, if you want to create some rendering, photorealistic effects, if you want to apply in your 3D object, 3D CAD object, we can do also in SolidWorks. Then in detailed drawings, we can create bill of material tables, cutting list tables, costing reports, then all type of different reportings we can create in SolidWorks. We do not need to use different softwares for that particularly applications. Then we can also create some piping works, electrical cabling works, some HVAC, heat ventilation, air conditioning diagrams. We can do anything. Like we can say that this software is one-stop solutions. We can do anything. Fine. Now I will share you my screen of SolidWorks software. Okay, fine. This is a SolidWorks 2020 software. Okay, this is SolidWorks 2020 software screen. In SolidWorks, we can create part as well as assembly as well as detailed drawing. Just choose your appropriate modules before starting. If you want to create some 3D part modeling, then just click on part and then okay. If you want to create some assemblies of different parts, then we have to select assembly mode. And then if we have to create some detailed drawings from your 3D already created parts or assembly, then select drawing and then give okay. First, I have to explain about the procedure of SolidWorks software. Okay, SolidWorks software procedure is parametric modeling. Okay, main procedure, main fundamental, main applications, and main advantages of this software is the parametric approach. What is parametric approach? Parametric modeling means if we design some object or part, then if we have to modify in future, remaining other parameters, other dimensions is also change and modify accordingly automatically. Okay, I will give some basic example. I'm opening a part modeling. This is the basic part modeling GUI. Okay, graphic interface of part modeling. See, we have three plane. First is front plane, then top plane, and then a right plane. Okay, we have to select the plane according to our appearance, according to our view. If we have to draw some top view, then we have to select top plane, then front as well as right. First I will sketch on top plane. I'm selecting top plane and draw a rectangle. Dimension value is 200 by 100. Okay, now if we have to apply a parametric relations between these two dimensions, okay, in future, if I change this 200 from to 300, and this dimension also we have to modify because this line is half. Okay, half than this line. That means this line is double than this. Then we have to again modify manually. Then apply 150. But we have to apply some parametric relations. Then just go to tools and go to equations. Apply some variables. If I apply a variable named a, and the value of variable I will give 300. Then give OK. Now in this 300, I want to define this parameter is equal to A. Then just double click, erase this value. Now apply is equal to global variable A, and A value is 300. Now again give OK. One symbol, earth symbol is here. That means this dimension is assigned with some equations. The again symbol is showing. Okay, now in this dimension, erase this dimension is equal to global variable A divided by 2. See, the automatically 150 is arrived. But in future, just open your dimension A and change any value. This is 500, right? A is equal to 500. Then this dimension is automatically changed. That is 250, right? Because we applied A by 2. So this is parametric. So due to parametric relations, your design modification time will be reduced. Okay. You can create some designs very much, very and very fastly. Okay. So this is the basic example of parametric design, parametric modeling is modeling. Entire software is parametric, and not the SolidWorks only is the parametric. Right now, every CAD softwares adopt this parametric relations and parametric reference concept. This parametric relations concept founded in Creo. Okay. The software name is Creo, formerly known as ProE, Professional Engineers, that developed by PTC. That software is founded in 1985. Then after, so many softwares like SolidWorks and other softwares adopt this parametric relations concept from ProE. Okay. Now, other procedure, other fundamental and further benefit of this software is associative concept. Associative concept means if we have a parts like we have different parts, okay, then if we create some assemblies from different parts, and then we have to create a drawing from that different part as well as assembly. In future we change and we modify some parts, the drawings will be automatically modified because of associative concept. All there is these three modules is like associative with each other. Okay, in part modeling, again, I'm going some example. In part modeling, see, I create some object like sketch a drawing on some front plane. In front plane, I create some line. I'm hiding this plane. Okay, now give dimensions. This line is 50. This line is 60. This is 100. This is 25, and this is fine. Okay, and I'm giving some 3D extrusion. So we have extrude feature. Basic feature is extrude. Extrude is for to give Z direction, to give heights in your 2D drawing. If we have a 2D drawing like this, and we have to apply some third directions in straight direction, in linear direction, then we have to apply extrude feature and select this drawing and give your height here 150, then apply 150 and give OK. Now I've saved this feature on my desktop. Name is just one. If I have to create some drawing from this part, in file we have options of make drawing from part. Just click on make drawing from part. In comes Okay, our title block and all. Now apply your views. Which views you want to define in your drawing? As per third angle projections, this is the front plane, this is top plane, this is right plane, this is isometric view. See, this is automatic. Now define your scaling. If we have to apply some scale, 1 jam 3. See the scale, and now automatic dimensions in even in annotations we have model items. Just define your dimensions. See, which we applied on part modeling. All dimensions is visible. That is automatically right. The drawing, your your drawing is ready. Okay. No need to create automatic like manually drawing from like AutoCAD. In AutoCAD, we have to create this drawing manually. All views you have to create manually. Front view, top view, right view, as well as isometric view. But in SolidWorks, this drawings will become like automatically from 3D part. In future, if we have to change in this part, then just open that part. Just open that part, change as per your requirement. If this not 60, this is 35, right? Then the change is this is 85 only. Okay, just give again, save, just close. See, your all drawings become automatically modified. This is 35, 45, this is 85 height. Fine. So this is the concept of associative concept. Part, assembly, and drawing. All three modules is associative with each other. So good, fine. In SolidWorks, in part modeling, see, this is the feature bar. This is the feature ribbon. In feature ribbon, there are so many features for solid part modeling. Okay, the basic feature is extrusion. Then again, we have a revolve feature, swept feature, loft feature. This is engineering and modification tools like holes and some cutout features. This is the extrude base feature. This is extrude cut feature. This is revolve base feature. This is revolve cut feature. That means this feature is for cutting your object. Like this is sketch, and again a view. This is rectangle. Apply some extrusion. Okay, this is your part. Now if we want to cut out from this face, then again sketch and select this face for drawing. Just sketch. I want to create some circle. Then circle. Then in feature select extrude cut. This is again extrude, but this feature, this object, this cut from this object like this. Okay, so there are so many features like this. Then this is some modification tools like fillet and chamfer. Filleting is for like uh, break your sharp edge and define some sharp curvature to edge like this. This feature gives curvature to edge. Then chamfer feature is cut your sharp edge and define some area. This is chamfer feature, right? The filleting and chamfering. We have some holes feature. This is totally standardized. If we want to create some standard holes, just define your positions. This is my positions and select your hole type. This is hole. Okay. Define your standard. Select standard like Australian standard, British standard, as well as Indian standard, ISO standard, German standard. Okay. So select your standard. I'm selecting some ISO standard. Then type of holes, tap drills, screw clearances, drill sizes. I'm selecting tap drills and define your size. I'm selecting some M27. Okay. And end condition is blind value. Like up, if I want to create some throughout hole, then throughout and give OK. See, this is hole. So if you want to create some patterns, multiple objects, like if we have this one hole and we have to create some 4 to 5 holes in a specific distance, specific equal distance, then apply linear pattern, select your direction, okay, and apply some distance between two components and apply value, how much quantity you need. See, this is pattern. Then we have reeb as well as draft as well as cell feature for hollow object. Okay. Then we have this advanced features in insert bar. Then this is for surfacing. If we have to create some complex object like automobile bodies, okay, two-wheeler bodies, some aeronautical bodies, dex board, then we have to design from this surface model. Then we have sheet metal module also. This is separate. If you want to like create some fabrication detail, fabrication drawings from create from sheet metal, then this is sheet metal modules. So die punching, bending, that process we can create from this sheet metal features. Okay, just give you example. If we have some basic wall, flange wall, like this is sheet metal object, this is a bending. Then if you want to create some again a band, then again sketch, define your bending edge like this and apply bend. See, all sit bend from this sketch line like this. Okay, if you want to create some punching, we have specific toolbox design library. We have some forming tools, ready-made forming tools given by Dissolve Systems like this. Just drag and drop. This is punching. Okay, fine. Now in assembly mode, we have so much like big library of ready-made standard components, like all type of fasteners, all type of bearings, all type of standard gears. Okay, like just click on design library and select this toolbox, add in now as per your standard, like IS standard, ISO standard, German standard, Australian standard, American standards. We have the different library. I'm selecting ISO standard. See, we have bearings, we have bolt and screws, keys, nuts, then O-rings, pins, as well as power transmission, all type of gears, structural members, and washers. Okay, in bearings, just click on bearings. We have ball bearing as well as roller bearing. In ball bearing, we have angular contact ball bearing, extrusion precision ball bearing, radial ball bearing. just define and select your required bearing standards. Okay, just drag and drop here. Okay, and now select your module size. This is your module size. This is all standard. This is standards. Just select your standard and size like this. Okay, the bore diameter is 240, outer diameter is 320, thickness is 60, number of ball is full, display, that is detailing, cage. If you want to add a cage, then select add cage. See, the cage is added. The full configuration name is ISO standard 15 ABB 39240 full DEAC full 68. This is the standard name of this bearing. So no need to create manually this standard components like bearing as well as some fasteners and all. Again, if you want to call some fasteners, then bolts and screws. If we need some hexagonal bolt structural, we have hexagonal bolt structural grade C ISO 7412 or 7411. This is 7412. And now selecting your size M22. Okay. Define size as well as washer face or chamfer face. Okay. If we need some washer face, so this is washer face. See, length, how much length you need, like this. Thread length and schematics. Thread display, yes. Bolt is also automatically create. This is all from library toolbox. So no need to create manually. Fine. In transmission, power transmission, we have some gears as well as chain wheels. In gears, we have helical gears, internal spur gears. Okay, that is a bevel gears, straight bevel gears as well as straight bevel pinion gears. If we need some uh, bevel gears, that is a gear, just drag and drop. Select your module size. Okay, and in define module size as well as number of teeth. How much teeth you need? We need 30. Okay, then pressure angle. Define your pressure angle. Then face width, hub diameter, mounting distance, keyway, and nominal shaft diameter. Just define. This is nominal shaft diameter. Just give OK. Your gear is ready. Okay. If we have to create some manual, if we want to create some this gear manually, then go to part. We'll create some gear, right? Fine. Just sketch on top view and hide. Extrusion. We need almost 25. Fine. Now sketch on this face. I'll draw some teeth profile. Again, extrusion up to this face. We have this one teeth ready. Then select this teeth and apply circular pattern. Define this face, and in full 360-degree we need 30 teeth. We'll reduce some teeth. This 20, 20 is okay. 21, fine. See, your gear is ready. Now, I'll save this object in desktop, name gear 1. Okay, just close it. Now, if I want to create some assemblies of two gear, similar two gear. Okay, off gear ratio is 1 jump 1. In assembly, call this object. Okay, now assemble this object with the matings. We have three type of matings. This is standard mates, advanced mates, as well as mechanical mates. In mechanical mates, we have gear joints. Okay, first we have some front plane. So first is this is top, top with top. Top with top, and front with front. First I will create some axis of revolutions. Okay, now apply this gear. In mats, we'll define this face as well as this axis is a concentric, coincide. Like this, and this face with this face. Fine. See, this is rotations. Now I apply second gear. Again, this is my second gear. Just define some axis. Again, creating some plane. Almost 75, 150. this plane and this. We need axis like this. Then just give mats this face and this axis, this face and this. Fine. This is individual gear, this is individual gear. Now I want to define some connections between these two gear. Then define mats, give mechanical mats and gear. Select this to face and apply ratio, gear ratio that is equal 100 diameter and 100 diameter. Okay. Now see, I'll rotate this some one gear, then opposite gear is automatically run. This is gear joints like this. So in like this, we can apply all type of mechanical joints like cam and follower, as well as some slot mechanism, as well as some hinge mechanism. This is gear joints, then rack and pinion, then screw joints, as well as some universal joints. Okay, see. I'll show you some examples, some ready objects that then you can like uh, see that applications of the software. This is the outer body surface design of Audi R8. Okay, see. Only body, outer body. We have to define all parts individually. See, this is the wheel assembly. This is the individual wheel. In wheel, this is the wheel alloy. This is the different part. This is the tire only. This is the bolt. This is the brake disc brake, as well as this is the brake caliper. See, this is the logo of Audi. This is again created individually and then assembled it. We can create anything. See, This is the engine blower assembly. I will create some cross sections. This is cross sections. Okay. Now I'll apply, see, all joints. See, you see all piston and cylinder working, crankshaft and all. Okay. This is the butterfly valve assembly. This is the working assembly. See, like this. Loader assembly, like JCB. All joints. See, you can see all joints. See. So we can do all type of behavior analysis too. All kinematic joints, kinematic analysis, FE analysis. I will show you some examples of finite element analysis, stress analysis. I will create some bracket. This is 100 by 100. L profile, L bracket, right? I'm defining some material. See, we have proper like standard material library. This is steel grades, all type of grades, iron grades, aluminum alloys, copper alloys, titanium alloys, zinc alloys, other alloys, plastics and all, rubbers and woods, everything. In steel, if we applied some ASI 304 stainless steel, right? 304 stainless steel, then all mechanical property of this material is the software have like density as well as Poisson's ratio, tensile strength, thermal expansions coefficient, etc., etc. Now, in SolidWorks simulations, define new study of static structural analysis. Give OK. Now define your fixtures. First, as a finite element analysis, define your material. After material selections, define your fixtures. Like if your product is fixed with some different environment, or rolling or sliding, or fixed hinge or elastic supports, we have fixed geometry, this phase. Okay, now if you want to apply some external loads as a boundary conditions, then force, torque, pressures, gravitational force, centrifugal force, bearing load, we can apply anything. Like I applied some forces on this phase. How much force? Something 250 Newton. Fine. If you apply some, this is static force, right? If you apply some non-uniform distribution, we can also apply some non-uniformly. Okay, this is uniformly applied. Okay. Now apply some massing. For finite element analysis, we will study in 6th or 7th sem in CAD subject. That is finite element analysis, FEA. Define massing, apply some mass quality. This is massing. Massing is to diffract your object. And now software will give us the value of deformation and stress on every elements. This is elements. See, this one triangle, this is one element. Now run this study. This is the result. In result, we have 1 mises equivalent stress. The maximum value is 5.44 into 10 raised to 0. That means 5.44 megapascal stress. At this red value, red color shows the maximum condition, not the failure condition. Software give us the maximum and minimum conditions. We have to calculate the failure ratio from factor of safety. Factor of safety is your tensile strength divided by your design stress. Our design stress is 5.44, and in uh, stainless steel 304 stainless steel, the tensile strength is almost 350 megapascal. So 350 divided by 5.44, that is your factor of safety. Okay, this is your stress. Then in deformation, this is that your deformation value is 1.55 into 10 raised to minus 2. That means 0.01 mm deformation. You, if you want to apply some animations, see, this is the animation. That's but 250 Newton force, nothing will happen. But now I apply some different material. Then I will apply some plastic. In plastic, I apply LDP, low density plastic. Okay, so we have to run again and value. I apply some 1000 Newton. See, the value is 2.18 into 10 raised to 1. That means 21.8 megapascal stress. Here, deformation is 6.20 into 10 raised to minus 2. That means 0.06 mm. And strain value, this is your strain value. You already studied this type of concepts, right? In first and second year, strength of material, mechanics of solid. If you want to create some reports from this analysis, see report. Some problem in Microsoft Word because this report is created in Microsoft Word, but in my system Microsoft Word have some issues, so report is not generated. No worries. We have some different plot tools if you want to create some section clippings like this. We can see some internal solutions. Okay, this is mass sectionings, the mass element. This is the element wise showing result like this. Okay, now we have some mind-blowing feature like costing. Okay, if you want to create some estimation from your design from your CAD model, then I will call some component like this boom cylinder. Now in material I will select that is AISI 1020 mild steel. Okay, now in costing, for costing we have to in evaluate, we have costing modules. In costing modules, define your method of manufacturing from machining or casting or plastic or 3D printing. Just select your manufacturing process. If we have to create this object from casting, then select the casting, then define launch editor, means a template editor for cost report. Means now currency mode is INR, just change USD, INR from USD, Indian Standard Rupees, right? And apply your real material cost here, like this aluminum alloys, copper alloys, plastic, and steel. In steel, define block or plate. Your object stock type is plate as well as block, and thickness as well as cost. Cost right now we have USD per pound. Just define your value like INR per kg. Just change your value. Then this is the plastic materials, this is casting materials. Now casting, apply your mold cost, then waste material percentage and cycle time. This is the material costing. Then machining, drilling, milling, machine centers, apply your machine time, loading, unloading time, labor cost, setup time. Okay, the cutting, end cutting, plastic injection molding, die cast molding, apply your costing as well as timing. Then operations, cut, milling, drilling, turning, and cut. Okay, and finally rules, terms and conditions for costing. Fine. So this is the cost like editor for this costing template. Now begin cost estimation. As per class, material is some other alloys and apply some aluminum alloys. Define your material, and material cost is something zero point 0.9 USD per pound. Molding cost, total time is cycle time is 15. Mold cost is 1000, that as per our input. Waste material is something as per our input. Quantity, how much quantity you need? I need 50 quantities. If you are to add some shop rate, that is $25 per hour. If you want to apply some discount, then again on discount 10%. See, the report is 24.57 USD per part. That is material plus manufacturing plus labor cost, everything. Breakdown is material percentage, manufacturing 10%, molding cost is 81, markup that is 9%. Okay. Now, if we apply 5000 quantity, see, the cost will be 5.2.52 USD per part, because now more cost will distribute. So for higher quantity, our regular formative manufacturing, means regular our method of the casting is okay, is good. But for smaller quantity, casting method is not appropriate. Okay, for a smaller quantity, 3D printing as well as machining process, formative manufacturing as well as additive manufacturing is a good uh, method. Okay, so this is the costing analysis. Okay, fine. This is the features of SolidWorks. We can do anything. We can create a part assembly, detailed drawing of single part as well as some major assemblies. Okay, and we can do weldments, structural weldments. We can do some analysis of CFD as well as FEA2 as well as kinematic analysis. Okay, Kausal sir, I'm done from my side. Just
Yes,
continue.
yes, sir. Yes, sir. Yes, sir. It's a introduction, sir, from your side, and very much knowledge sharing from the starting as a history of
Hmm.
solid work, and it can be at it can so the steps have for such a knowledge sharing session from your side. Thank you, sir.
Thank you. Thank you, sir.